What do we do with the collected waters that we use in households and industries? We'll dump them in the environment? Well, no! Welcome to the lecture series Introduction to Urban Sewage Treatment as part of our water treatment course. My name is Jules van Lier and I'm Professor in Wastewater Treatment and Environmental Engineering at the Sanitary Engineering section of TU Delft. In this part of the course we will discuss the characteristics of urban sewage, as well as the common treatment technologies that are applied in the Netherlands. In our follow-up master courses, we are focusing on advanced technologies, as well as alternative technologies that are recently developed to reach a higher degree of sustainability. Following the urban water chain, the treated and distributed drinking water finds its way to all households and industrial appliances. At both uses, water is generally used for cleaning or transport of waste products, and only a very limited amount is actually used for drinking. In fact, less than 1% of the water supplied to the households. Therefore, the used waters contain many suspended pollutants. And in addition, because water is a polar solvent, many pollutants will dissolve in the water. The water, which is suspended and dissolved pollutants, is now called wastewater or sewage, and is carried away from the site of use. Collection of the used urban waters is generally done by means of an extensive sewage network, which conveys the urban sewage to the site of treatment. The term used urban waters over wastewater in fact better describes the state of the water and therefore has my strong preference. Moreover, wastewater implicitly is negatively valued, water that is wasted and it needs treatment prior to discharge into an environmental sink. Used urban waters is more positively and calls for treatment for reuse. This can be the water itself or the various pollutants that can be recovered as a resource. In fact, the term used urban waters better fits in the urban water cycle idea, the central theme of our entire course. The collected sewage is treated at a sewage treatment plant or wastewater treatment plant. The sewage treatment plant consists of several functional units, each targeting a specific group of pollutants. Such unit may consist out of physical treatment, chemical treatment, biological treatment, electrochemical treatment, or combinations of these types of treatment. We have to realize that every single cubic meter of drinking water will ultimately become 1 cubic meter of wastewater, and that may impact many cubic meters of surface water, or even groundwater, when it is discharged without treatment. Since the self-attenuation of these waters is very limited, such discharge will lead to severe environmental impacts. In order to protect the environment, financial investments have to be made to establish treatment technologies. And particularly in congested areas or urban settlements, uncontrolled discharge of large sewage flows is conceived problematic. We also have to realize that large areas in the world are yet deprived from adequate sewage collection and proper treatment. For instance, in Latin America, less than 20% of the sewage is collected and treated, whereas in Asia this is less than 40%. Here in the Netherlands, about 100% of all households are connected to the sewage network, and finally to a sewage treatment plant. In this part of our introductory course, we will specifically discuss the setup and functionality of the sewage treatment plants that are currently in operation in the Netherlands. What will we learn the coming lectures? First, as any disciplinary field, also wastewater treatment engineering has its typical terminology. We need to acquaint ourselves to this terminology. Second, why do we need to treat these waters? Or in other words, what is their environmental impact when they are discharged untreated? Third, we need to understand the nature of the pollutants and the characteristics of the sewage in general. Fourth, how does a sewage treatment plant look like and what are all the functional units in fact doing in the treatment plant? By finishing this course, we should be able to design a full-scale sewage treatment plant using the design features commonly applied in the Netherlands. How does a sewage or wastewater treatment plant look like? This picture shows the largest sewage treatment plant in the Netherlands, here in Delft. It has the capacity to treat the sewage of about 1.4 million people. It's a modern treatment plant that removes organic matter as well as nutrients, phosphorus and nitrogen from the used water up to the restrictions set by law. This picture looks great, right? But how does it function? The sewage treatment plant consists of various treatment units, of which some make use of physical removal and other of biochemical removal. You see screens, settling tanks, bioreactors, excess sludge treatment facilities and more. The effluent of the treatment plant is low in organic pollution and low in nutrients. You will see this slide very often in the course, and every time we will discuss a functional unit inside this treatment plant, we will indicate exactly where we are in the treatment plant. We hope that this approach will facilitate your comprehension of the entire treatment setup without getting lost in the various functional units. And since when do we treat the urban sewage? The obligation to treat the sewage up to standards prior to discharge follows the deplorable state of our surface water in the 60s of the past century. Lifeless surface waters were common and species diversity was at stake. Only in the early 70s, the Clean Water Act was approved by our government, and from that time onwards it was forbidden to discharge without treatment. At the same time, a cost recovery system was invented. This appears to be successful up to date, the polluter pay principle. And what does this polluter pay principle mean? Well, every person daily discharges a certain amount of carbon and nutrients. This amount of pollutants is, therefore, denominated as person equivalent, abbreviated by PE. The person equivalent of pollutants is subsequently translated in money, in cash. Consequently, every person receives a bill for the cost that are required to treat these pollutants. And up to date, we pay up to 80 euros per person per year for supporting the institutions who are responsible for reaching the requested water quality at the treatment plants. In this way, it is also easy to calculate how much an industry has to pay when it discharges a certain amount of pollutants. Just divide the total amount by the person equivalent amount. The untreated discharge of organic matter was already forbidden in the Netherlands early 70s of the last century. However, the uncontrolled discharge of nutrients, phosphorus and nitrogen was only regulated in the 90s, in agreement with our neighboring countries in the so-called North Sea Treaty. At present, we expect even stricter regulation as set by the European Framework Directive and adapted Dutch regulations. And were these regulations effective? Well, yes. This table shows the average influent and effluent values of the major sewage pollutants. The organic pollutants are indicated by the parameter COD and BOD, which will be explained later in the course. Nitrogen pollutants are indicated as total N and phosphorus as total P. The settleable solids are termed as SS. In every sewage treatment plant, the effluent restrictions are met, as you can see. In the Netherlands, in all treatment plants, the biological reactor plays a central and crucial role in meeting the requirements. Particularly the requirement for treating the nutrients nitrogen and phosphorus to a low level decreased the amount of organic matter in the effluent drastically, as indicated in this table. Therefore, biological treatment is often considered the central core of the system and will be discussed in detail in this course. As already mentioned, the fortunate condition we have in the Netherlands is not yet achieved worldwide. In fact, waterborne diseases are a major killer. We have to realize that worldwide, every hour, about 200 people, mainly children, lose their life because of these waterborne diseases. This makes about 200 million people per year. These numbers were collected by the World Health Organization in the year 2000, when the Millennium Development Goals, or MDG, were approved. The numbers speak for themselves. About 1 billion people do not have access to safe drinking water, which is particularly a problem in developing countries in Africa, Asia and Latin America. And note that about 2.4 billion people do not have access to sanitation. Again, the major hurdle has to be taken in developing countries. But were these MDG agreements effective on this? Well, no. In fact, with regard to the sanitation, the situation aggravated, and now some 2.6 billion people have no access to proper sanitation. A shame. The reason for this incredible backlog are multiple and quite complex and go beyond, in fact, the scope of this course. In industrialized countries, we have a full legislative and institutionalized backup to protect our environment and prevent non-controlled discharges. This leads to strict control and implementation of the laws. Also, the already mentioned polluter pay principle is widely adopted, so industries and individuals actually pay for the required treatment. Moreover, public perception here is strongly in favor of environmental protection, although we realize that this costs money. How different is the situation in developing countries? Although many countries have similar restrictive laws as the industrial countries, there is little institutional backup and very little control and implementation. In addition, cost recovery is hardly implemented, so there's an extreme lack of financial resources. But needs are high as the scarcely available fresh water resources are more and more threatened. Now, we realize that this course will not solve the world problems on waterborne diseases. But we do want to freely distribute our knowledge on sewage treatment so that anybody interested can take his or her advantage of it.